Today we're going to be looking at solving polynomial equations, section 5-3 in your book. Your objective is going to be to solve polynomial equations by factoring. The standards that we're looking at is MA 912, Algebra 4.9, 4.3, and 4.10. First thing we're going to look at is solving with GCFs. We've worked on GCFs before, and we will continue working with them. So our objective is to find what are the real or imaginary solutions. Here's our first one we're going to look at. First, you always need to still be equal to 0 in order to solve. So we're going to begin by subtracting 3x to both sides. So we get 2x cubed minus 5x squared minus 3x equals 0. Next, we're going to look for a GCF. The GCF that all three of these terms have in common is x. So we take out an x, and we're left with 2x squared minus 5x minus 3 equals 0. Continuing our factoring from chapter 4, we're going to do 2 times negative 3. Leaving the x outside, now we have x squared minus 5x minus 6 equals 0. What are the factors of negative 6 that make negative 5? This would be negative 6 times 1 and negative 6.
Mr. Vila, please call the front office. Mr. Vila, call 5420.
And negative 6 plus 1 to make negative 5. So it factors as x times x minus 6 times x plus 1. Now if we multiplied by the 2 to change the problem, remember that we need to turn around and divide by 2. And we're still equal to 0. So now our factors are x minus 3, and x plus 1/2. To solve, we're going to say x equals 0. There's one answer. The next answer will be x equals 3. And the last answer will be x equals negative 1/2. We have 3 zeros to match the power of 3 we had in the original problem. Here's another one. I would like for you to try this one. Pause the video, find the GCF, replay when you are ready to see the answer. So for this one, once again, you need to get it equal to 0. So we have 3x to the 4th, and then, let's get that 4 back there, and then minus a 6x cubed, and then a plus 12x squared equals 0. Make sure that they always go in order from highest power down to lowest power. So it goes from 4 to 3 to 2. This time our GCF is a 3x squared. So when we take a 3x squared out of this first term, you're left with x squared. Take a 3x squared out of this term, and you're left with a minus 2x. Take a 3x squared out of this term, and you're left with a plus 4. This time there are no factors of 4 that make negative 2. So the first one we can solve by setting it equal to 0. Divide both sides by 3. X squared equals 0. Then take the square root, and x equals plus or minus 0 or 0 with a multiplicity of 2, because positive 0 is the same as negative 0, and every square root gets plus or minus. So there are 2 answers there. For the second answer, we have to take x squared minus 2x plus 4 equals 0. It won't factor, so let's get rid of the negative 4. So now we have x squared minus 2x plus box equals negative 4 plus box. You could also use the quadratic equation to solve that if you did not want to complete the square. Remember, to complete the square, we need to find that c equals b divided by 2 squared, which will give us 1. So we're going to put a plus 1 in both. Now remember that this factors as x minus 1 squared, because the factors of 1 is 1 times 1, and then 1 plus 1, and you always keep the middle sign. And it equals negative 3. Take the square root of both sides, and you get x minus 1 equals plus or minus I root 3. Then add 1 to both sides, so the final answer is x equals 1 plus or minus I root 3. So we have 2 real answers over here and 2 imaginary answers over here, making a grand total of our 4 answers from our original problem. Now let's look at factoring sum or difference of cubes. There are 2 formulas that you need. If you have a cubed plus b cubed, then it factors as a plus b times a squared minus ab plus b squared. If you have a cubed minus b cubed, then it factors as a minus b times a squared plus ab plus b squared. So let's look at an example. X cubed minus 27. We can look at these 2 terms as perfect cubes. If I do x cubed, that'll make x cubed. And then over here, if I do 3 cubed, that'll make 27. And I know this because 3 times 9 makes 27, and then 9 is 3 times 3. So I have 3 3's that make 27, meaning 3 cubed. So A is x and B is 3, still equal to 0. So when I go to factor it, my first parentheses, because this is a minus, is going to follow the second formula. So it will be a minus b in the first parentheses, and that will be x minus 3. The second parentheses will be a squared. Since a is x, when I square it, it becomes x squared. The second term is a times b, so I have to do x times 3, which makes plus 3x. You do not use that sign. Make sure to follow the signs in the formula. Then last, you have a plus b squared. So we put a plus. Since b is 3, when we square it, it becomes 9. All still equal to 0. So now we take our first parentheses, x minus 3, set it equal to 0. Solve by adding 3 to both sides, and we find the first answer as x equals 3. For the second half, we take x squared plus 3x plus 9 equals 0. There are no factors of 9 that will make 3. Since the middle number is odd, we do not want to complete the square. This leaves us with the only option of using the quadratic formula. So we determine a equals 1, b equals 3, and c equals 9. Now let's plug into the quadratic formula. X equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 9 all over 2 times 1. Using our order of operations, we find that negative 3 plus or minus the square root of 3 squared is 9, and 4 times 9 is minus a 36. So 9 minus 36 makes negative 27 all over 2. Now we need to break down 27. 27 is 3 times 9, and 9 is 3 times 3. So we can make a group to bring out of the root, as well as we need to bring out the negative. So now x becomes negative 3 plus or minus 3i. The 3 for the group we made, and the I for the negative. Square root 3 for the leftover 3 that did not fit into the group. All divided by 2. Since there's nothing else you can reduce, that becomes your final answer. So you have one answer over here, x equals 3, and then two answers here for the plus or minus, which gives us the 3 total answers for the degree of the original polynomial. Let's try one more of those. 64x cubed minus 1. This time we have not only a variable in the first term, but a number as well. So when we find what cubed will make that first term, we have to think about the 64 and the x. I know that 64 is 4 times 16, and 16 is 4 times 4. So 4 cubed will make 64, and x cubed will make x cubed. Minus 1 is an easy one. The cube root of 1 is just 1, so that 1 cubed still makes 1. This time a is 4x and b is 1. There's still a minus sign in the middle, so we're still going to use the second formula from above. So our first parentheses becomes 4x minus 1. This time a has two components to it, a number and a variable. So when we go to the second parentheses, we have to do a squared. Since a is all of 4x, we have to square both terms. Squaring the 4 makes it 16, and squaring the x makes it x squared. Plus, now we have to do a times b. So 4x times 1 makes 4x. And then finally, the last, we do b squared. Since b is 1, 1 squared is still 1. To solve, we take our first parentheses and we set it equal to 0. So 4x minus 1 equals 0. Add 1 to both sides, and we get 4x equals 1. Then divide by 4, and we find that x equals 1 over 4. There's our first answer. Once again, to find the second answer, we have to try and factor this second quadratic equation. Once again, it will not factor. There are no factors of 16 and 1 that will make 4. If we multiply 16 times 1 and get 16, there are no factors of 16 that will make 4. So to factor this, or to solve this, we need to use the quadratic formula again. So we're going to say x equals negative 4 plus or minus the square root of 4 squared minus 4 times 16 times 1 all over 2 times 16. So here we go. -4 plus or minus the square root of 4 squared makes 16 minus 4 times 16 is 64 all over 32, which is 2 times 16. Then 16 minus 64 becomes -48. Now let's factor 48. 48 is 6 times 8. 6 is 3 times 2. 8 is 2 times 4. And 4 is 2 times 2. So we have a group of 2 here and another group of 2 here. So if we begin simplifying, the -4 will stay out front. Plus or minus, if we're taking out 2 groups of 2, that will make a 4. Once again, it was a -48, so there needs to be an I. And then left over inside the root is this lonely little 3. All over 32. Now if we look, 4, 4, and 32 have 4 in common that we can divide out. So if we continue to simplify, we get -1 plus or minus I root 3 over 8. That's dividing a 4 out of all 3 of these terms. 4 divided by 4 makes a -1. 4i divided by 4 makes the I. And then 32 divided by 4 makes the 8. Once again, you have 2 answers here because of the plus or minus. 1 answer here, making the 3 from the degree of the original polynomial. I know that these are tricky, so try them in your Moodle assignments and bring in your questions tomorrow at class. We will practice more of these tomorrow. Now let's look at factoring by grouping. We use grouping when there are 4 terms, like this problem here. To group, we will group off the first 2 and the last 2 using parentheses. Then you look at the first group. What do they have in common, or what is the GCF that you can take out? Both of these terms have an x squared in common. So we take out an x squared, and what's left is x plus 3. Then we look at our second parentheses. This parentheses has a positive 4 in common that we can take out, and what's left is also an x plus 3. Now, if you notice, both of these terms have the group x plus 3 in common. So we take out that group, x plus 3, and what's left is x squared plus 4. It's like factoring, just using a different method. If you FOIL them back out, you would get the original problem. Now that we have 2 linear factors, we set each one equal to 0. So we say x plus 3 equals 0, subtract 3, and we find that x equals -3. Set the second parentheses equal to 0 and solve. So we would subtract 4 to both sides, and we find that x squared equals -4. Then take the square root of both sides, and we find that x equals plus or minus 2i. Don't forget that every square root gets plus or minus. Because it's negative, it will be imaginary, and then the square root of 4 is 2. So there's 2 more answers here, making a grand total of 3, which is the degree of the original polynomial. Remember that the number of answers should always match the degree. Last thing we're going to do is look at factoring quartic equations. Factoring a quartic is not much different than factoring a quadratic. They work very similar. So let's look at the first example. Because this is an x to the fourth and this is an x squared, it's like a quadratic that goes from 2 to 1 to none, but it goes from 4 to 2 to none. So we're going to factor it just like a quadratic equation. What are the factors of -8 that make -2? That would be -4 times 2, or -4 plus 2. The difference when we factor a quartic equation versus a quadratic is the first terms will be x squared and x squared, so that x squared times x squared makes your x to the fourth. This one will be a -4, and this one will be a +2 for the two factors we found. Just like quadratics, now that we have linear factors, you can set them each equal to 0. So we can say x squared minus 4 equals 0. To solve, we add 4 to both sides, find that x squared equals 4, take the square root, and we find that x equals plus or minus 2. And that gives us 2 answers. To find the 2 remaining answers, we will say x squared plus 2 equals 0. Subtract 2 to both sides, and x squared equals -2. Take the square root of both sides, and x equals plus or minus I root 2. The negative becomes the I, and since the square root of 2 is not perfect, you leave it as the square root of 2. Once again, there's 2 more answers there because of the plus or minus. 2 answers here and 2 answers here makes the total of 4 in the degree. Here's another quartic. Notice that this has no middle term. Just like in quadratics, we have to find the factors of -81 that make nothing in the middle, since there is no middle term. That would be -9 and 9, or -9 plus 9. -9 times 9 will make your 81, and -9 plus 9 will make your 0 in the middle. So it factors as x squared minus 9 and x squared plus 9. These work like your perfect squares. X to the fourth is a perfect square in that you can reduce it as x squared squared. 81 is also a perfect square in that you can make it 9 squared. So we use the x squared and the 9, one negative and one positive, so that it will make a -81. Same as always, now that we have linear factors, we set each one of them equal to 0. So let's start with 9x squared equals 0. Add 9 to both sides. X squared equals 9. Take the square root, and x equals plus or minus 3. Do not forget your plus or minus. That's what gives you 2 answers here. Now let's do the other one. X squared plus 9 equals 0. Subtract 9 this time, and x squared equals -9. Take the square root of both sides, and x equals plus or minus 3i. There's another plus or minus to make 2 more answers, making a grand total of 4, which is the degree. Remember that the number of solutions you have should always match the degree of the original polynomial. There was a lot of factoring in this, some of which you already know, some of which is new. Go back and look through it as you're working on your Moodle assignment to help you with any of the problems on there. Bring in all of your questions tomorrow, and we will practice this more tomorrow.